and welcome to the Data Architecture Virtual Chapter Meeting for June 2019. Today we're happy to have Amir Baig to talk to us about performance tips and tricks for migrating to Azure Data Warehouse. I think that's something we're all going to find very interesting. Here are some of our upcoming chapter meetings. We've got Glenn Berry in July on the 10th, and Ryan Adams in August, and Tim Radney on October the 9th. You can register for those and anything else that we haven't announced yet on our website, dataarch.pass.org. We're very happy to be sponsored again by Nutanix, and we've actually got a couple of folks here from Nutanix today to talk to us a little bit before Amir gets started. And then our second sponsor of the group is HVR Software. They've been with us for a couple of years as well. We're very happy to have them. Please reach out to them and thank them for their continued support of our virtual group. Pass Summit 2019 is coming up in November. If you haven't registered yet, I'm going to show you a discount code in a couple of slides that you can save $150 on your registration. New this year are learning pathways. It's a pretty neat little concept where they're going to have a bunch of sessions in a row that are all related so you can follow sort of a path. The Modern Migration Tour 2019 coming to a city near you. Actually, as soon as I get off this call, Thomas LeBlanc and I are going to do one here in Baton Rouge. So if you want to learn how to migrate your soon-to-be end-of-life SQL Server 2008 instances over to something more current, this is a good place to get to do it. We're going to do some labs and some demos there. An upcoming Facebook Live event on June 26th with Melody. You can go to Facebook and see more about that. There's that code I told you about. If you want to save $150 on your summit registration, use that code there. And if enough of you guys use that code, I think they'll give us a little kickback that we can give back to the group. Upcoming virtual group webinars, you see us there at the top there for today, but there are several, just about every topic and language you can think of. Find more information on the PASS website at pass.org. And lastly, upcoming SQL Saturdays, topic near and dear to my heart. You can see right there in red, I've put our Baton Rouge one on August 17th. We've got a pretty great schedule lined up, so if you can make it out to one of those or one of the 4 or 5 that are happening this weekend, they're like mini PASS summits. It's something you really want to check out. So before Amir gets started, Michael and Brett from Nutanix, if you guys would like to say a few words, the floor is yours.
Yeah, I appreciate everybody having us on the call today. So my name is Michael Dillon. I'm account executive for Nutanix here in Louisiana. Appreciate everyone's time. I'm going to let Brett introduce himself, and we can talk for a couple minutes about what we do. And again, appreciate everyone having us on today.
Yep, and my name is Brett Wish. I'm the local enterprise systems engineer for Nutanix here in the New Orleans, Baton Rouge area. In fact, I'm a recent transplant from Dallas as well. So just getting used to the area.
Awesome. I guess what we can do, how many people in the room actually know, I don't know if this is a full response, Kenny, or what, but you want us to kind of, I guess, explain who we are just a bit, or most people in the room know who we are?
Yeah, why don't you go ahead and just introduce yourselves a little bit and talk a little bit about Nutanix. They can't respond. They can chat if they have questions.
Okay, great. Yeah. So yeah, at any point, if you have any questions, please just put them in the chat window, and we'll definitely follow up as we continue. So just a little bit about Nutanix. The company started in about 2009 with the concept of looking at how Facebook and Oracle and other what we call web scale companies were building their infrastructure, building something that was effectively invisible to the end users and the administrative staff. You know, you don't have to go in and build out manual silos of components to put them together to make an overall solution. So for us, when we first started out, it was originally just with hyper-converged infrastructure, taking storage and moving it into your individual hypervisor servers, allowing you to then just add on servers and configurations of storage as you needed to, and expand it all as a virtual pool and manage it as a single virtual pool. Since then, we've added a lot of additional functionality and features into the Nutanix infrastructure and the ecosystem. One that's really particular and dear to databases in general is a new product of ours called Era, where we can actually do manage database deployments and automated deployments, automated backup management, and snapshot management. So if you're using SQL Server today, for instance, you want to go out and you want to deploy a database, but then you also have to go out and deploy the database server and all those other ancillary components. You can use Era to automate that whole procedure within Nutanix itself without having to go out and actually manually deploy a virtual machine, install SQL instances on it, and get it configured. You can all basically develop it in a way that makes it all policy driven, to where you don't have to go back to your server team or your infrastructure team every time you need to do something, which is especially useful if you're doing database clones from a production to a test dev environment, or if you're doing Oracle and needing to do backups or snapshots similar to something that you may be doing with RMAN today and having a script. So basically what it does is it effectively we make a lot of the administration of infrastructure become a lot more simplified, a lot easier to do, and a lot more streamlined.
Deal. So, and just to kind of chime in, I appreciate everybody's time. So, I look at where we've come from, and again, we started in that hyperconverged story. We talked a little bit about the shift of some of the guys really taking a look at consolidating the data center down to one pane of glass to be able to manage infrastructure, and now even moving into a hybrid cloud model, which I think ties into what we're hearing about today, and giving customers the agility to move applications between clouds. And so, we're telling a great story, seeing a lot of traction, and appreciate you having us on, and we're looking forward to getting to know you all a little bit better as a result of these regular cadences. So appreciate the time, Kenny.
Oh, you're very welcome. Thank you guys again for your continued support. And so with that, Amir, if you're ready, I'll go ahead and make you the presenter.
Yes, please.
All right. Here we go. All right. Thanks, everybody. And take it away, Amir.
Hi, guys. My name is Amir Baig, and this is the topic that we will be discussing today, migration to Azure Data Warehouse, especially from the performance tuning perspective. Here is my introduction. I basically been working with SQL Server and Oracle starting from version 6, which sounds pretty embarrassing now, but I worked with version 6 of Oracle, 7, 8, 9 up till the latest 12c. My area of expertise, most recent area of focus is business intelligence, cloud data warehousing, and ETL. I have also worked on the Azure and Data Warehouse as well as the Amazon one, so I can give you some sort of a little bit on the comparative analysis if I get the time as well. I'm based in Houston, Texas, which happens to be the oil and gas, main area of United States. That's why most of my experience has been in oil and gas, energy related fields. Once upon a time, I used to teach for Learning to International. It's the largest software training institute in the world. I used to teach databases, both Oracle and SQL Server. I have not been doing that for a while because of the fact that my kids don't let me go. So what we're going to talk about, Azure Data Warehouse, as you know, there are so many dimensions, so many areas with respect to the loading, performance tuning, optimization, but I have to, since my time is restricted to 1 hour, we're going to talk about why Cloud Data Warehouse is a good option, and what is MPP-based architecture, massively parallel processing. And my primary focus is the last two circles that you see here, that how should we design objects, meaning primarily tables. This is a topic which in the classical relational databases, we don't really worry about how we design table. We just create table statement, we define In Oracle, just table space and SQL Server, even that is not a question. But in Azure Data Warehouse, this becomes very relevant, that how we design our tables. It has a huge impact on performance and tuning. That's why we're going to dedicate some time, a major portion of this talk on this topic. And then we are also going to talk about loading the data. What are the best practices? Can everybody hear me properly? Kenny, you can hear me fine?
Yes, sir.
Okay, fantastic. So why move to cloud? As you know, there was a time when whenever a new data warehousing project starts, it takes a bunch of meetings with infrastructure folks, DBA folks, the business, trying to figure out and try to estimate how many concurrent users are going to be, what kind of, how many processors we need, what is the range of memory that we need. All of that is just out of the window because of the fact that we have the capability to scale as we desire. But it's not something that we start with and we get stuck, but we can scale as our processing demands or our memory demands increase. We can actually scale accordingly. So one of the, besides all the reasons which are jotted down here, the most important is quick to deploy, meaning that if you have the knowledge and the skills, you can deploy your data warehouse within an hour. Compare that to weeks and weeks of meetings that you have with different groups to figure out the bandwidth, to figure out what kind of hardware you will need, and it goes into, if not months, it takes weeks to before you even see the box. So that is, I think, it's very quick to deploy. And the other reason is that your storage, you're not confined by the local storage on the box, and you're not even confined or restricted by your storage area network. However big your storage area network is, it has a finite limit. But when we're talking about Azure Data Warehouse or in general in cloud data warehousing, the limit is really huge. It goes into petabyte magnitude. So you can increase your storage as much you want. It is not infinite, but I think there is some finite limit. But in most of the cases, I think petabyte is good enough for most of the businesses. Another good point of moving to the cloud is fully managed. You don't have to worry about patching. You don't have to worry about maintenance hours and backups. It's totally managed by the cloud. Another reason is the disaster recovery. As you know, building a disaster recovery solution is a month-long exercise or multi-month-long exercise. You have to decide your remote data center, you have to worry about bandwidth, you have to set up software and replication, whatever methodology. And in a cloud environment, especially Azure cloud environment, it's a matter of a couple of clicks. And you can create your disaster recovery or read-only replicas in a different location. Another reason that which I think is the number one reason is the horizontal scalability, which you see here that, and this is kind of emphasizing the point of MPP-based architecture. There's the concept of compute nodes, and as your load changes during the course of the day or during the course of the year, you can actually horizontally scale. This is, in my opinion, the number one reason that you want to move to the cloud. You can have up to 60 compute nodes, and we will see that in detail in the slides coming up. And another reason is your accessibility. And if your Azure Active Directory, if you have access, your security is properly set up on Azure Cloud, you basically can access it from anywhere, whether it's your IT team, whether it's users. So this is, I would think, is another reason that you want to move your data warehouse from on-prem to the cloud. So the number one reason of horizontal scalability it hinges upon the massively parallel processing engine. What that means is that if you look at the top, so the user queries hit the control node. There's a concept of control node and there's a concept of compute node. So these compute nodes right now in this figure are listed as 4 compute nodes. You can take it up to 60 compute node. So what happens is that you run a query, your query hits the control node, and the control node actually splits that into X number of compute nodes, and that is through which you get the massively parallel architecture. And the difference between on-prem, you can have 16 processors in on-prem or 20 or any number of processors. But the thing is that there is a concept of scalability here that you can go up to 60. The other concept which you will not see in Amazon data warehouse is the decoupling between the compute node and the storage node, meaning that suppose you have 12 terabytes of data right now in your Azure storage, which will be incurring you certain cost. But as far as the compute layer is concerned, it is in your control that during the load time where you need a lot of processing power, you can increase the number of compute nodes so that your load can take place overnight in a short span of time. So the cost variable is the computation power. At that time, the storage is not computational, is not part of the computation. So the decoupling between the computation layer and the storage layer is I see as the distinguishing factor between AWS and Azure. So if you look at the previous slide, and this is sort of the brief description of that, the control node is the brain of the data warehouse, meaning that's where everything enters and that's where everything exits out. And it's only one node. The compute nodes can range either the computational power of the data warehouse. It can vary from 1 to 60. It can vary from 1 to 60. And there is a service which is running on every compute node. It's called data movement service. This is the service which is responsible for moving the data from one compute node to the other when you are running the queries which needs joining between the tables, and this service actually collects the data from different storage buckets. That is the concept of distribution, or you can say that there is the concept of storage and there is a finite amount of buckets that you have, which is 60, meaning that in Azure data warehouse environment, suppose that you have a table which has 60 million rows, and if we are using the distribution methodology of round robin, which we are going to discuss, then you will see that the 60 buckets, each bucket will have 1 million rows spread across 60 nodes. So if you want to get straightforward maths, how data warehousing unit is the computing power, which is it has computing power, it also has the memory within it, and it also includes the temporary database. And we will see in the slides down how they are connected together. So one compute node, if you multiply that by 100, that translates into 100 data warehousing units. So the maximum is 60 compute nodes, meaning if you multiply that by 100, the maximum data warehousing units you can have is 60,000. So this is the picture I would like you guys to have in mind that will enable you to understand the architecture, and you may want to print it and put it on your cubicle. If you see here that the application, the user hits the control node right here, and that load is distributed across, this is the layer of the compute node, and this is the storage layer. If you see, we are seeing 60 buckets, or you can call it 60 distributions. So there are 3 layers. One is the control node, which is the entry and exit point for all the data. The second layer is the computing power, which can scale from 1 to 60. And the third layer is the storage layer, which is fixed. Now, the concept is, depending on how many compute nodes you have, you will be allocated certain number of distributions for that particular compute node. So in this scenario, you're seeing 4 nodes, right? We have data warehousing, we have selected the power, which data warehousing units is equal to 400, which translates into 4 compute nodes. And if you divide 600, which is the number of storage buckets or distribution, 60 divided by 4 comes out to be 15. So if you see that this compute node is talking to these 15 buckets, the next compute node is talking to the storage buckets starting from D60, D16 to D30. The third compute node will be talking. These are like, for those of you who have the DBA background, a SQL Server instance minimum has 2 files. One is the MDF file where the data resides, and there's a log file which is called LDF file. So you can say that potentially you can have, if you have 60 compute nodes, we're talking about 60 MDF files and 60 LDF files. So when you scale up or scale down, it actually changes the ratio between how many buckets one instance of compute node will be talking to. So I hope that this thing is clear, that this is when you scale up or scale down, there is a process of detachment or attachment takes place, which actually determines that how many storage buckets a compute node will be talking to. And that is another picture which can help you in this situation. Azure Data, you will see 6 compute nodes, and if you see 60 divided by 6 is equal to 10. On the right hand side, you say one compute node will be talking to 10 storage buckets, and each storage bucket has 2 files, one MDF file, one LDF file. We are talking about 20 files. So that way you can understand. So this is a straightforward way how you will define, you create a database, create database MySQL Data Warehouse. Addition, actually, on the same instance, you can create a classical database as well. So, if you want to create a SQL Data Warehouse, Azure Data Warehouse, you will have to say addition is equal to Data Warehouse, and then you define something called service level objective. So if you just want, this is an example where just one compute node is going to have DW100. And you can also define what is the max size, and you can modify this later. You can also do it through scripting as well. Now, as far as the data warehousing units is concerned, if you look at the left-hand side, it starts with 1. When one compute node, meaning data warehouse 100, it can go up till 6,000. That is 60 compute nodes. You can do it with alter database statement as well, but you can also do it using the Azure portal by moving this bar to the right-hand side, and it will actually go and tell you that how much it's going to cost you. And you will be surprised that even if you're using 60 compute nodes, your bill is less than $100 an hour. And of course, you don't want to run on 60. And we will see that what is the best, depending on what is the size of the data and your access pattern, what is the best DW data warehousing unit value that you should use. So data warehousing unit actually defines your computing power, CPU. It also defines how much memory is available to you, and it also defines what is the bandwidth, what is how much read and write capacity that you will have. This is sort of, if you have this question in mind, or how many DW data warehousing units should start with, this is sort of a starting point. And you say if you have, right now your existing data warehouse is somewhere between 8 to 12 terabytes. So the range that you can work with is starting from 3 compute nodes, which is 300 data warehousing unit, and you can go up to 600. This sort of a starting point is really a function of, it's not just a function of how much storage it is, but it's also a function of what your access pattern is, what is your concurrency load, and how much heavy you are on the write side versus heavy you are on the read side. So this sort of gives you an indication that sort of a starting point that if you want to go up till 160 terabytes and above, then you probably are talking about 2,000 data warehousing units and above. Now, besides the storage, there is another limitation in Azure Data Warehouse, which is called the concurrency. How many read operations or how many concurrent active users you can have. And the memory on each compute unit, compute node, is a function of what kind of resource class you use. Resource class you can say in database, like you have database roles. So depending on that you define your resource intensive queries, you will be assigning that a role of, for example, extra large resource class. And for your medium kind of queries, you will go with medium RC. So you can actually assign your user ID with a role, and role could be one of these 4 roles, small RC to extra large RC. And depending on which role the ID is assigned to, when you run a query using that ID, then that role kicks in, and that determines that what is the maximum limit on the megabyte on one compute node that will be allocated to, this query will be allocated to. So for example, that you are working with, we take the, the example of this one, 1600. So you have, suppose you have a user ID, you assign the role of medium resource class. What that means is that when you run the query, the maximum memory which is available to that query is 1600 megabytes. So if you think that the amount of data that that query needs to process is sufficient to is such that 1600 megabytes would be good enough, then you will be assigning a resource class of medium, otherwise you will have to bump it up. So on this graph, you actually see that how much memory, as you increase the computing power, corresponding to the computing power of how much you have more memory to work with. And you can only figure this thing out once you understand your access patterns, once you understand what kind of load you are presenting to your data warehouse. Another concept in Gen 2 Azure Data Warehouse is temporary database. Temporary database, as we know, those of you who have a SQL Server background, whenever any sort of aggregation takes place in a query, whether it's average, whether it's sum, or you are doing a count star, then the query has to create a plan in such a fashion that it uses temporary database. So each compute node has a temporary database attached to that. And we have to understand in Azure Data Warehouse environment, we don't have magnetic disk. All the disk and storage we are talking about is SSD, solid state devices. So what this graph tells you is that what is the size of the temporary database which is attached to your compute node. So if you are running a query which requires a lot of sorting, which requires a lot of aggregation kind of activities, then you have to settle with a data warehousing unit so that your temporary database is able to handle those aggregation activities. For example, if you have, for example, with the data warehousing unit of 1,000, you're talking about 10 compute nodes. So at this point, it is close to, this one has close to 50. This one will be basically for one compute node, the temporary database sizing is close to 400 gigabytes. So if you're talking about 1,000, so this goes up to close to 4 terabyte. You have the amount of the temporary database. So you have to decide that what kind of queries you're running, and depending on what kind of queries you're running, whether your temporary database can handle all the sorting, all the aggregation kind of computations or not. So that is another factor which actually determines that what kind of computing power, how many compute nodes or how many data warehousing units that you will decide. Because there is no hard and fast rule. Every environment is different. So you have to understand your access pattern. Now, one of the main things that you will have to decide is the table geometry or table distribution options. When you create database in SQL Server and Oracle, you don't have much options. In Oracle, you have where, you know, the concept of table space, that where you want to land your table. In SQL Server, there is a concept file gross, but most of the time, with the latest technology, you don't really worry too much about it. But it's very important in Azure Data Warehouse that how you want to spread out your table storage across 60 buckets. That's what table distribution methodology is all about. And this is, in my opinion, one of the key factors which will determine that how optimized your data warehouse will be. So in other words, by default, when you create a table, the default methodology is round robin. What that means is that if you have a table which has 60 million rows and you do not define the table distribution methodology, that 60 million row table will be distributed across 60 buckets or 60 distribution of 1 million each, which may be okay in certain situations when you are loading the data into a staging table. That is the best methodology. But when it's time to read the data, when your dashboard and your Power BI reports are talking to Azure Data Warehouse, then round robin is not the best strategy. The other simple strategy is replicator. So we have three primary methodologies: hash, round robin, replicated. The round robin is the default, meaning that the data in each table is distributed across 60 buckets uniformly. What replicated is if your table is of not significantly high size, then you can afford, because storage is not that expensive, you can actually copy that table across all the 60 buckets. And this methodology is called replicated. This the data is repeated on every node. It simplifies many query plans because wherever your fact table is, your dimension table is also there. The most complex thing is hash distribution. So data is divided across node based on hashing algorithm. The same values will always hash to same distribution. And Azure Data Warehouse, as of now, just allows single column hash values. But if you're working with Redshift, which is the equivalent product from Amazon, actually they do allow multi-column hash functions. So in a single column, what that means is that suppose you have product ID as one of the primary keys, and you have 1,000 distinct product IDs in your in one of the fact tables. I'm not talking about dimension tables, I'm talking about fact tables. And you have 60 million rows. So what happens is for every distinct value of product ID, when you apply the hash function, it's going to land on the same storage bucket. So you want that your fact table as well as your dimension tables, if the connecting columns are the same, then you want to use hash distribution strategy for your fact table as well as for your big dimension tables. And I think this is explained in the next slide. So in any data warehousing environment, we are talking about three distinct type of tables. One is when you load the data from OLTP systems, you aggregate them or you straight load them in whatever fashion they are in the source OLTP system, you load them into staging tables. The second type of tables in a data warehousing environment are the dimension tables, which are typically not that big, but the biggest tables in size are the fact tables. And as you know, in a star schema, a fact table is in the center and the dimension tables are connecting to it. So these are some of the guidelines that for small dimension tables, which are less than 2 GB, so the recommendation is that these are not huge in size, you can replicate them. You can replicate them across different distributions. And for the fact tables, so fact tables by default are big, or the big dimension tables, the preferred method is hash distribution. Why it is preferred method? Because when you're running the query in a star schema, there's always connection between dimension tables and fact tables. And if your connecting column is the same data type and you apply the hash distribution method, the rows which are connecting together will actually reside on the same storage bucket, and that will minimize the data movement. And this is one of the objectives when you are designing your tables, you want to minimize the data movement across compute nodes. So if you're just straightforward loading the data, then round robin is the best strategy. If you're not clear about access pattern, you can start with round robin, and then later on there are some queries, there are some ways that you can see that data movement is taking place. When data movement is taking place, you can convert your strategy from round robin to say replicated, or from round robin to hash. You need to make sure your common hash keys have the same data types. And the most important point is this, that the frequently joined fact and dimension tables should be hash distributed on same common key. And I'm sure you guys are familiar with the clustered column store indexes. So indexes also play a huge role in the performance tuning aspects of things. So for large tables, it is the best choice is clustered column store index. As you know, the classical way of storing the data is to row-wise storage, but in column store indexes, the columns are stored together. So one column, all the columns within this entire tables are lumped together, because in data warehousing environment, there are more aggregate kind of queries, and the aggregation is usually on measures or on those columns which where the arithmetic computation takes place. And if they are together, then the performance is really much better. So if you do not define the index methodology, the default is the column store. Heap meaning a table which does not have any index. When you are loading the data from your external source system, the best strategy is first to bring them into heap, and then you can do some transformation and make fact tables out of that. Cluster tables, clustered index is good if your table has less than 60 million rows. These are some of the guidelines that you can use. Non-clustered indexes, you can use it, but as you know that the more non-clustered indexes you have, the write operation increases the transaction length, and that can hamper your performance. So statistics, as you know, the optimizer makes a decision what is the best way to execute a query. It makes a decision based on the statistics. So it's extremely important that your statistics are up to date. So which columns you want to create statistics on? Well, ideally, you at least want to have statistics on the columns which are the connecting columns between dimensions and fact tables, where the group by is taking place, where the where clause is. So these are the minimum number of columns you should definitely have statistics on. And if you are doing incremental loads, then your statistics taking your jobs which updates the statistics should be much more frequent than your classical statistics. If needed, you can use multi-column statistics, you know, on those columns which you are using simultaneously in the queries. Auto create update statistics in preview, and so right now you have to actually do the computation. You have to design jobs which actually compute the statistics. But auto statistics, it is available in SQL Server. It is not available in Azure Data Warehouse right now, but it's slated to be there soon. So now the question is that when we prepare the data to come to Data Warehouse, generally speaking, you will not replicate all your existing processes to build your Azure Data Warehouse from scratch. What you will do is you want to check out what is the performance of your Azure Data Warehouse based on your existing load. So for that, you will actually move your most demanding fact and dimension tables first to Azure Data Warehouse, and you run your queries, you run your dashboards and see whether the performance, what is the level of data warehousing units which is good for you. So initially you will be doing from your existing on-prem data warehouse, you will be moving a finite amount of fact and dimension tables to Azure Data Warehouse to build the processes, to find out how much time it takes and what kind of performance under what kind of data warehousing units, because that is also a function of what is the cost that you will be incurring over an extended period of time. And then you compare that with on-prem cost versus in-cloud cost. So what this bullet is talking about is that you have to do sort of a testing phase by taking your most demanding fact and dimension tables to Azure Data Warehouse. You have to establish your standard dedicated connectivity to the cloud. You can have dedicated, if your bandwidth is the issue, you can have dedicated connectivity, which gives you much bigger bandwidth. And it is critical that depending on where your existing data warehouse is. If your data center is suppose in Texas, then you have to select an Azure region which is closest to you. You don't want that your on-prem data warehouse is in Sydney and then you select a region which is in Virginia or something like that. So the geographical proximity also matters, that where your what is the best destination for your data warehouse. And we were going to talk about more in detail that Polybase is one of the best ways to load the data in a fast fashion. And Microsoft has guidelines from SQL customer advisory team, which actually publishes the benchmarks in terms of what are some of the speeds that they are able to get. Because you have to measure, for example, you have your data warehouse is 12 terabytes, and you load data every night from your source system, even if it's a full load or it's a delta load. Suppose you load 6 terabytes. So you have to find out how much time it will take to load 6 terabyte of data in Azure Datawarehouse. You have to do those computation. We'll be discussing some of those benchmark pretty soon. So the recommendation is Polybase in terms of what is the best way. SSIS with Azure 2017 feature pack and Azure Data Factory. These are the fastest ways you can load the data. I think I have quite a bit number of slides that I have to go through. I have to be running fast here. And then there's a concept of resource class, which I discussed earlier, that when you are running the query, you have to make a decision between concurrency and how much data or memory you want to assign to one query. So there is always so Azure Data Warehouse from concurrency point of view has some challenges. So you have to make sure that you balance between when you're loading the data versus the user are accessing it, what is the maximum level of concurrency that you want to achieve. The beauty in a cloud environment is that suppose you can scale, meaning that overnight when you are loading the data warehouse, you can increase your data warehouse unit to up to 6,000 max, and we will see down that we can actually load up to 6 terabytes per hour. So if you have to load, for example, 12 terabyte of data, you can get it done in 2 hours, and then you shrink your compute nodes. When the users come in the morning, you shrink it down to, say, for example, 5 node. That should be good enough for your read load. But when you need computing power in terms of when you're loading the data, you can scale back. The only challenge is that when you shrink or when you expand, all the existing in-flight transactions have to be canceled. So you have to make sure that you are not running something which is of significant value, or you are scaling at a time when the load is minimal. So this is basically recommendations from SQL CAD group, that for your best performance, Polybase is the best strategy, where you define your external data sources using a metadata structure inside Azure Data Warehouse, and it works in parallel. That's why it gives you the maximum. And Azure Data Factory SSIS with 2017 on feature is also good. But Azure Data Factory, SSIS, and Polybase, these are the way. If you have huge amount of data, you cannot even think about BCP or SQL bulk copy APIs, because they're not going to give you much bandwidth. So Polybase is the best strategy, and Azure Data Factory actually and Polybase are not two mutually exclusive options. When you are designing your load packages in Azure Data Factory, there are some features. You just check certain boxes they actually enable the polybase feature so that you can simultaneously load the data from your Azure storage into your data warehouse. So Azure Data Factory has the capability to work with the polybase polybase functionality. These are some of the characteristics. Load performance scales as you increase. Service level objective, we already talked about it. Depending on your need, overnight you can have huge number of data warehousing units, and at 6 a.m. you shrink it back when the users come in. They are just running the reports. You don't need so much computing power. And your throughput is also depending on data warehousing units. I want to show you so these are some of the query performance recommendations. You have to see how your data, suppose you have one table, you want to see where exactly most of the data resides. So remember, you have 60 buckets, right? And you are using hash functionality. But even then, if your data is scattered all across, this means that was not a good candidate for hash partitioning. So with this DBCC command, you can actually look at the table, that how it is distributed across 60 buckets. And then you can decide whether hash methodology is good for this or not, and how your objective is to minimize the data movement among the compute nodes. You need to make sure the statistics are there. The best strategy is create external table as select, because that does the minimum logging, or you can do create table as select directly. You can denormalize the table. You can look at the query plan, how the load is distributed across compute nodes. So one of the things that you have to keep in mind is that you have a limitation on how many readers you can have. So suppose you have a data warehousing unit of 300, you have maximum 24 readers, meaning if you are loading the data and you have loading the data and you have sliced, suppose you have a huge table, you have sliced it into 60 text files, and you're assuming that they will be simultaneously read. That will not be the case, because depending on which data warehousing unit you are using at one particular time, you have a limitation how many readers. Even if you have split your data into multiple files, you have a limitation how many readers at one time you can have. So you need to know how your data, when you are importing the data into data warehouse, what is the best strategy for your large fact tables or for your large tables, how you will slice it so that you can get the benefit of the maximum number of readers who can read from it simultaneously. So yeah, the problem is that if you have the data in the compressed format, the parallelism, the parallel reading does not work. So if you split the data across multiple files, that maximizes the load performance. These are again some of the values in terms of how many readers or writers you can have. And based on this, based on the number of tables you have to load, what are the size of those loads, and what is the maximum number of readers you can attain with certain data warehousing units, you will decide, you will fine-tune this strategy with the passage of time, that what is the best data warehousing unit that will work for you. And these are some of the benchmarks that I wanted to talk about. One thing here. So the takeaway from this slide is that you have to use the resource class properly, meaning that if you want to use high number of data warehousing units, but your query is not being assigned an appropriate resource class, what will happen is that your data warehousing units will be going in waste because you have not defined the proper resource class for your queries. So you have to, I think the most important thing is that you have to understand your workload, what kind of read load you have, what kind of write load you have. The write load will define what is the size of the temporary database that you need to have, and that will determine that while you're loading the data, what is the best value for data warehousing unit, and because that is gonna affect your bill. So when you're loading the data, what is the optimal value of data warehousing unit in terms, because that determines the size of the temporary database, that also determines the size of the memory which is available on one compute node, and that will eventually determine that how fast you can load the data. Similarly, when your data during the day, people are running the dashboards and all of that, you have to understand that pattern as well. And depending on, suppose you have certain queries or certain dashboards which are very busy, so you will be running it by assigning the resource class so that it gives you the maximum utilization of your data warehousing unit. So doesn't matter even if you're using 60 compute nodes, but if your resource class is not being appropriately assigned to your read or write load, then your bill will still be high, but you will not be satisfied with the performance. So this slide is very important. I think you need to keep this in mind while you're deciding. And this is some of the benchmark results. On the x-axis is the number of compute nodes right here. And on the y-axis is how much you'll be able to load gigabyte per hour. So if you see that the maximum achievable goal when you have 60 compute nodes, and you'll see that you are able to reach up to 6 terabytes per hour. So if you're loading, for example, the data warehouse that I'm dealing with, it's somewhere in the vicinity of 10 to 12 terabytes. And we are loading close to that much data, almost 80% of data every day. So if you horizontally scale to 60 compute, you can actually do the entire process in less than 3 to 4 hours. So this is actually will tell you what is the maximum capacity that you can achieve. And on average, for per node, on average, you will be loading up to 110 gigabytes per hour. So you multiply that to, for example, 60. That will determine what is the maximum capacity. So you have to settle somewhere in between. And this is the megabyte per second, but I think this graph is much more important, as it gives you the maximum capacity. But in general, if you are using less than 6, in general, you're using around 6 nodes, I have seen that basically the maximum capacity is like around somewhere around 250 to 300 gigabytes per hour, which is not bad. So that's pretty much, let me see what time I had. I think I'm almost there. I thank you very much for your time today. If you have any questions,
Thanks, Amir. We do have a couple of questions. If you've got time, or we can answer them offline. That's easier for you.
Yeah, I think I can probably take a one question or so, and then I think the other ones I can respond offline.
Okay. Well, I'll go ahead and ask this one since he asked about it just now. Can I assign a medium RC role to use when my data warehouse is using a max of DW100 compute?
So if you're using their 100 compute, okay, yeah, you should be able to. If you look at the graph that I had presented, it actually gives you the what are the maximum. And I think that if you have a 100 compute node, you should be able to use the medium resource class.
I think, and then yeah, if you want to take the rest of these offline, I'll shoot you over everybody's questions and email addresses so you can answer those.
Sure, I can do that.
All right. Well, excellent. Thank you very much. I learned a lot from this. I hope everybody else got a lot out of it. I'll get the recording cleaned up and posted this evening, and we'll send out an email to the group to let everybody know where it is. Thank you all for coming today. Amir, thanks again. I really appreciate your time today.
Thank you, Kenny. Thank you, everybody.
Everybody have a great day.
Thank you. Bye-bye.
Bye-bye.